Thank you. Thank you. Thank you, ma'am. Thank you, ma'am. Thanks, sir. All right, just to let you guys know, just so you guys know, some of my earlier classes had asked if I'm able to, on some of the days when I've been gone, I've been recording the lessons, and then also for anyone who was sick, I was recording the lessons and trying to put them onto Google Classroom. Because of that, I'm just going to record the lessons as I teach them for the day. Excuse me. So as I teach the lesson for the day, and then I will post that onto Google Classroom, and then actually it'll be on YouTube. I've got like one that just has my name, kind of. You saw it when we did the last lesson. So it'll be there if you need to go back through the lesson again, if like the notes just don't make sense, but you want to watch an actual video. I will have the entire lesson posted onto that YouTube channel so you can kind of go back over it and relearn it with me if you would like to. Okay? Also, it'll be the entire class that goes through it. So like, that's my microphone. Here's my YouTube starter kit up here. So if you're going to watch the lesson again, just know that there will be a lot of wait time, so you can go ahead and fast forward through those parts. Okay, so lesson 4, the stuff we're doing today. We are doing rectangles. Okay, so rectangles themselves, you're going to be able to identify and recognize the properties of rectangles, and then determine whether those parallelograms, if they're rectangles or not. So for you telling me, because it's been quite a while that you guys have been working with rectangles, not in a lot of details, but you've seen them for a lot of years. If you had to describe a rectangle to me, and I'd never really seen one before, how would you describe a rectangle? What is a rectangle? Jack?
A longer square.
Okay, so it's a longer square. All right, I'll put longer square. What does that mean?
Stretch.
Okay, stretch. Well, how about this? I don't know what a square is. Okay, so it's gonna be four-sided. I like it.
Four-sided shape. Each four-side, each side equal.
Okay, so then I'm just kind of gonna go back to what a rectangle is. So it's got 4 sides. So I've got that. What else? What else is the same? What else is similar?
The top and the bottom of the 2 sides.
Perfect. Okay, so the top and the bottom. Are the same. I'll put the same length. And then sides. We'll do that. Okay, the sides are the same length as well. What else? Jack?
90 degrees.
Fantastic. Every single corner, every corner is 90 degrees. Okay, so you guys got it. Again, a rectangle means that they're going to have the exact same length for the top and bottom, or 2 sides are going to be the exact same length. The other 2 sides will be the exact same length. And then every single corner is going to be 90 degrees. Okay? They've got a couple theorems on there. I'm going to draw my own little pictures of the theorems so that way you can kind of help identify it. Because as we get into these shapes, there's a couple rules that we're going to have that will make a lot more sense. You guys have seen them before. Anybody need more time with that? So here's my picture of a rectangle, and I'm just going to mark the sides. Okay, to go with what Delaney said, the top and the bottom are going to be the exact same length. So I'm going to make this little hash mark to show they're the exact same length. Okay? The other two sides, these ones, are going to be the same length as well. Here's where I'm going to give you a little bit of extra information, kind of taking what we did from 2 lessons ago and then kind of put it into here. When we have a parallelogram, what do the diagonals do?
Show like the center.
Okay, it shows the center. Do you remember what each side? What was it? It starts with a B. Rhymes with a bisector.
Bisector.
Bisector, perfect. So that means that each side is going to be the exact same length. Sorry, I couldn't think of anything else that rhymes with bisector. So that tells me that this length right here and this length right here are the exact same length. Because it is a rectangle. These are all the exact same length. So all 4 of these will be the exact same length. So besides knowing what the outsides are, the top and the bottom are the same, this side and this side are the same, each one of the diagonals will be the exact same length. Okay, so that's what we can tell about the sides themselves. Because I don't want to get the picture way too busy, I'm going to give you some rules with that rectangle that deals with the angles. I'm going to explain it. I just want to give people a chance to write down this shape before I start explaining it. All right. Hopefully you guys all remember, every single corner is going to be a 90-degree angle. No matter what, they're 90s. But besides that, I'm going to get into a couple more details of the angles. Because of how that rectangle is going to be cut in half, this angle right here and this angle up here are the exact same length, along with this one and this one. So all 4 of these, this one here, this one, and this one, will all be the exact same degrees. Okay, if all 4 of those are the same degrees, that tells me that all 4 of these ones are the exact same length. So this one, this one, this one, that one. And another one, if I have this angle right here, if this one is going to be an angle, using the vertical angle rule from chapter 3, that tells me that this one, straight across from it, is the exact same set of degrees. And then finally, I know I've got so many lines on here, this one and this one are the same as well. I'm going to choose colors because I've got so many lines on this. It's hard to see them all. This angle and this angle match up.
Is this all we're doing? Or is there more?
There's always more.
So this is most of what we're doing.
Will it make you feel better if I say yes?
Yes?
Then I'll say yes.
Oh no, that's a lie.
It is a lie, but it is. I'm still going to say yes. Okay, so those are the angles. As long as you can understand this stuff, the rest of this lesson will go a lot really quick. Any questions on that? Okay. So I'm going to jump down to this shape right here. I don't know if you can see it with the plants, but it's a rectangle and it's got a walking path that dissects it in half. Yes, sir.
I'm just gonna all lines.
I'm going to talk in just a second. I don't want to go ahead, but I think you're in the right track,
Are all the angles and lines equal?
relatively speaking.
I have no idea what I'm talking about here.
Okay, so I've got that shape. I'm going to write the thing that they tell us down. They said that TS, again, I just redrew the picture, kind of like you would have it on your paper, so that way it doesn't have as much stuff going on. When you have all the trees and the people walking in the park, it's kind of hard to see. This tells me that the length of this one is 120. And I think what Jack was trying to get to, what he's trying to say is that based on what we had with that picture with all the lines, every single one of these lengths are going to be the same. So if this is 120, that means this is 120, this is 120, and this one's 120. So if it's asking me what the length of PR is going to be, PR isn't going to be just one of these little half segments where it goes from the side to the middle. It goes from one side all the way to the opposite side. What am I going to need to do to figure out the length of that whole entire section? Jack?
Addition,
Okay, yep, addition, what am I going to add? What numbers?
120 plus 120.
Perfect. Because I got two of them. I got this 120 here,
120 times 2.
and then I've got this 120 right here. So 120 times 2. The total length is going to be 240 meters. I forgot to talk about it before. Or I forgot to remind you about it before. The rule still applies though. How many degrees are in a triangle?
180.
What?
260. 180.
Which way do you want to go with?
180.
180 is correct. Okay, in a triangle, you got 180 degrees. So, based on that previous picture that I had, is going to help you kind of solve this one. This says that PRS, so PR to S, this angle right here is 64 degrees. Okay? Just because I'm going to make it a little bit easier with all my colors, I'm going to color in all the ones that'll be 64 degrees. So that's 64 degrees, that's 64 degrees. This one's 64 degrees. This one's 64 degrees. That was that picture that we had from before. Do you remember? Did you write that picture down from like at the very beginning
Of this lesson today?
of this lesson today?
Yes, I still do not understand.
You don't understand how these are all the exact same?
No, I'm not understanding much of what's going on right on this question whatsoever.
I really haven't got to what the question's asking yet. I'm just identifying the things that are the exact same.
Oh, okay.
So they told us this angle right here was 64 degrees. And based on the rule that we had, the theorem that I wasn't going to get too much into, but I drew all the pictures for, every one of these 4 angles here, this one, this one, this one, and this one, are all the exact same degree, the exact same measure. Okay? The next part they were asking is that 4 angle SQR. So S is here. Let me get a different color, sorry. S was here, Q was here, R was here. They're asking me about this angle right here. Okay? I know what this one is. I don't know what this one is. What can you tell me about every single corner in a rectangle? They're all 90 degrees. So I can take 90 degrees minus this angle, and it'll tell me what this one is. So I'm going to have, you can get that pen, sorry about that. I'm going to have 90 degrees minus that 64. So it'll give me 26 degrees. That tells me that this angle over here is 26 degrees. How you feeling, Matt? Give me thumbs up, thumbs down, wherever you're at. A little bit in the middle, all right. Lots up though. Okay. Does anybody need more time on this problem? Okay, I'm going to scroll down to the next example.
How many more things do we have to do?
You have this one, and then there is kind of a little bit longer one. But you have until 2:07 or 2:07.
Oh my god.
You're fine.
It's less than, it's a little
Is
less,
that-
it's a little more
is
than
that
half
the
an hour,
whole-
wait, it's not enough time.
No, it's not the homework part. It's just there's still like a half an hour left of school.
Okay. So I'm going to give you a chance to write this one down. While you write this down, I'm going to draw the same picture so it doesn't have the swirlies in it.
Oh, great. I'm outside. Uh-oh. No idea how to put this way. Good job, Derek.
Somebody left it there last week. Okay, so here's a real world problem. Okay, this is exactly what they do for gates. So you have this rectangular garden gate. In order to prevent it from sagging, you put in diagonal braces. Okay? It needs to be a rectangle. That means that this diagonal brace and this one need to be the exact same length. So I'm going to give you the pieces of information they give us. They tell me 12 feet. They say that LN is going to be 6.5 feet. And it says they want us to find KM. They want us to find this entire length here. Okay? Looking at this, does the 12 feet mean anything? Do I even need to care about it? No, they're going to give me too much information. Okay, but they do give me this as 6.5 feet. We know from that earlier picture that every single one of these segments is the exact same length. So how long would length KM be, Jack? 13. We're going to take that 6.5 times 2, or just add it together. We're going to do 6.5 plus 6.5. My total length that I need is going to be 13 feet. Again, some of these questions, actually a good chunk of these questions as we start going on, may have more information that will not pertain to the specific thing they're asking you. Make sure you understand what they're looking for. Okay, a lot of stuff up until now, like in your school career, has only gave you just the information that you need to solve the problem and nothing extra. Okay, as this year goes on, plus further years, they're going to give you extra information. Okay? I'm not going to worry about this because I've already drawn this picture. This just tells you that diagonals are the exact same length. Okay? I already explained that one to you. So, for us to figure out, we already know about these parallelograms. Okay? In order for us to figure out if a quadrilateral is also a parallelogram, we know because of the rules that we had that if we have a diagonal line, if both diagonals are the exact same length, it is a rectangle. You guys agree with that? So, if we know that if there's a diagonal that is the exact same length, and we can figure out that they're the exact same, then yes, we can solve it right away. And that's what these next two of them are. I'm letting you write stuff down if you'd like to. All right, so looking at this one, again, you don't have to draw it perfectly to scale with graph paper, but it is important to understand which ones are going to be the opposite vertices, so that way you know which ones are going to be the diagonals. So just kind of plot them out so that way you know where they're going to be at. So -2 and 3, this will be my first point. That'll be point J. K is going to be at 1, 4. So that'll be K. L is going to be at 3, -2. Whoops, yeah, that'll be L. And then M is going to be at 0, -3. So my shape that I'm drawing will look like this. For me to get the diagonals to figure out, is I'm going to need to connect the opposite points. So I will need to connect from point K down to M, and then point J over to L. Those are my diagonals. And if those diagonals are the exact same length, then I know for a fact it's going to be a rectangle. Okay. Mm-hmm. Okay.
Is this the longer one we have to do?
Yeah. There's a total of 2 of these. One will be distance, one will be using slope.
On the homework or on?
Or on the both. both here and there. So this one says to use the distance formula. Who remembers the distance formula?
I2 minus Y1.
It's like the square root of,
Yeah, this one's the square root of.
it's like x2 minus x1 squared
That's what I was
plus
saying.
y2 minus y1 squared.
I have an X then Y plus
So here's the deal. The x's and y's, it doesn't matter which order it is. If you do x2 minus x1, or if you do x1 minus x2, it doesn't matter. It will all work out the exact same. So I'm going to go through those steps in the way that I write mine, just so that way I can figure out what I'm doing. Is I'm going to write those letters to show you which ones I'm working with. So the first thing I'm going to do, I'm going to have my distance of JL. So the distance of JL, that tells me I'm going to have 3 minus negative 2 squared plus negative 2 minus 3 squared. That's minus a negative, so that gives me 5 squared plus negative 5 squared. All of that still within the radical. So I get 25 plus 25. So the distance of JL is radical 50. I can leave it as radical. I'm happy leaving it there. I don't need to know exactly how long it is. I just need to make sure that the other one matches up. If it does, then it is a rectangle. If it doesn't, it's not a rectangle. So I did JL. The other distance, the other one I'm going to use is going to be KM. So I'll put the distance of KM just so that way I know which one I'm doing. So between K and M, okay, for that one, for DM or KM, I'm going to do negative 3 minus 4 plus squared plus, sorry, those are the y's first. It'll still work out the exact same. 0 minus 1 squared. So that gives me negative 7 squared plus 1 squared. That gives me 49 plus 1. That one is a radical 50. Is this number the exact same as this?
Yes.
Yes, if they're the same. Yes, that's it, you're done. I'm going to highlight that to show you exactly what I got so excited about. This number here was exactly the same as this one. All right, the last part. This one says, determine if it's a rectangle using the slope. Every single angle is 90 degrees. Jumping back to 2 chapters ago, what can you tell me about the slope of a perpendicular line? Like, how about this? If I gave you the first slope, this is my example here. Oops, just kidding.
Is it the opposite reciprocal?
Yes. If my slope was 1/4, my perpendicular is going to be the opposite reciprocal. So the opposite reciprocal. So instead of having 1/4, it'd be 4/1. The first one's positive, this one would be negative. Okay? I want to give you a chance to write that so you can see what we need to figure out. Can't hold it? Thanks. Okay, same thing as before. I'm going to plot my points while you're kind of working that stuff down. I'm just going to roughly plot them so I know where they're going to be. So my first point will be over here. K is at -8, -6. Next one, L would be at 5, -3. And then my last one would be at 2, +5. Whoops. So I need to figure out if these slopes are the same, and then also if this slope and this slope are going to be the reciprocal. And if at any point they are not either the exact same slope or the reciprocal, the opposite reciprocal, we can stop and just say no. So I'm going to look at the slope, my slope of J and M, just so I can start off there. My slope of J and M, I'm using that formula, the y2 minus y1 over x2 minus x1. So with J and M, I've got 5 minus 2 over 2 minus -10. My first slope is going to be 3 over 12, or I can simplify that down to 1 over 4. So there's my first slope. My next slope I'm going to do is going to be K, or slope of KL. All right, so L is -3 minus -6 over 5 minus -8. So those are plus a positive. That gives me 3 over 13. I can't simplify it.
We're not using the distance formula for this?
Nope, this one I want to use the slope. Okay, I'm going to stop there. Are these the same? Are these reciprocals? No, stop. If they're not either of those, you can stop where you're at and just say no. Look at you taking your stuff from Dare from Winover. Nice work. Just say no. Okay?
Just say no.
The notes are already posted, but otherwise, the video will be posted momentarily, not momentarily, probably posted at 15 minutes from now. The assignment, page 260, 10 through 19 all, 24 through 31 all. Okay, if you want to double check your answers, you most certainly can do so. I do have it up here. You only have 2 that you're going to have to plot like this. The rest of them will all be kind of giving you one shape where you just figure out all the steps that go along with it. Yes, ma'am. Oops. Where are you?